Hello all, and welcome to MYP Masterclass for Chemistry. During today's video, we will be discussing states of matter and changes of state. As many of you know, there are three states of matter: solid, liquid, and gas, but we must now learn their identifying properties and how exactly we change from one state to another. First are solids, and here you can see a diagram of the arrangement of particles in a solid state. The particles are in a fixed, organized, and regular arrangement. This means that the substance can't flow, has a fixed shape and volume, and the highest density out of all the states of matter. Next, we move on to liquids. Here, we can see that the particles are no longer arranged in a regular position. However, the particles are touching, and they can move over each other, which will contribute to the fluidity of the liquid. Also, liquids will fit the container shape and will have a fixed volume and medium density. Finally, we have the gases. Here, the particles are in a random position, and the particles are not touching at all. Gases can flow, will fill a container, having no fixed volume and the lowest density of the states of matter. Now that we know the identifying properties of each of these states, we can learn the names of the changes of state. Here is a diagram presenting the 6 changes of state. You are likely familiar with melting, which is from solid to liquid, freezing, which is from liquid to solid, vaporization, which can either mean evaporation or boiling, which is from liquid to gas, and condensation, which is from gas to liquid. However, changes of state between gases and solids are somewhat new. A change of state from solid to gas is called sublimation, which you can remember by the first letter S of solid and sublimation. And from gas to solid, it's called deposition. Keeping this in mind, we can now question how exactly we change from one state to another. This varies based on the type of change, but in either scenario, it is linked to kinetic energy. If the substance is heated, we consider melting, vaporization, and sublimation. In these cases, the substances are being heated, which means that the particles are gaining kinetic energy and increasing their rate of movement. This will mean that the particles will be further apart, so they will change states, which we can recognize from the arrangements of the states as seen previously. On the other hand, as substances are cooled, they will lose kinetic energy and the particles will move slower, so again, they will change states. This will be the case for freezing, condensation, and deposition. These changes of state based on heating and cooling are illustrated by heating and cooling curves. For this example, we will be using water, which has very regular melting and boiling points, but it can be done with any substance. This is what the graph would look like, with temperature on the y-axis and time on the x-axis. First, we must identify the melting and boiling points. For water, the melting point is 0 degrees Celsius, and the boiling point is 100 degrees Celsius. At these points, there will be flat sections in the graph, because the energy in the increase of temperature will not be used to increase the temperature, but rather to make the particles move faster, be further apart, and thus change states. So, to draw the heating curve, you must draw a positive, meaning upwards, diagonal line from a point below the melting point up to the melting point. At the melting point, you can draw a flat line to represent the change of state. Then, continue the diagonal line up to the boiling point, where you will again draw a flat line. Finally, continue the diagonal line to the end of the graph. You must then label the sections accordingly. At the bottom, label solid. At the first flat line, label the melting point. Then label liquid, then the boiling point, and finally, at the top of the graph, label gas. So this is how to draw a heating curve. Cooling curves have the same process, except the diagonal line will be negative, downwards, as seen here. This is all for this topic. Thank you, and let me know if you have any questions.